Hi, in this video I'm gonna go over example 11 from the vector chapter 12. Okay, this is example 11 from chapter 12. This type of question is very typical IB question about vectors. So let's get started. Alright, so go ahead, pause the video and understand the setup of this question. Before you do that, I want to point out something. There's a typo, right? There's a typo over here. This is not XP, this is XB. Okay, XB. Alright, so go ahead, pause the video and try to understand the question yourself. Alright, welcome back. So here basically what we have is a triangle, and on the vertices I have point O, point X and point Y. And vector OX is they give us, I can represent vector OX as vector X and vector OY as vector Y, and the point A is right in the middle of OX, point B is right in the middle of OY, and point C is right in the middle of XY. So points A, B, C are the respective midpoints of their respective segments. Now for part A, they want us to find OA, OB, XY, OC, CO in terms of X and Y. So a bunch of vectors, but we need to express them in terms of X and Y. So OA, vector OA is simply, so OA starts from here, we go all the way up there, that's my vector OA, which is just half of your vector OX, correct? Half of your vector OX. And vector OX is equal to X, so I can rewrite this as half X. Okay? Now, the next one is vector OB. Vector OB is here. Right. And that is, again, half of vector OY. So vector OY is equal to Y, so this is just half Y. Okay? So far, I think we should be good. Then we have vector XY. So vector XY is this one, right? Which is the same thing as saying from X to O, and then from O to Y, right? This is the same thing as saying XO, and then plus O to Y, right? So what's XO? Vector XO is the opposite direction of vector OX, right? So I will have negative X for that, because OX is vector X, then XO is negative X, plus OY is simply Y, right? So that's my vector XY. Okay, now what's next? OC. They want us to find OC. So OC is from here all the way up to there. That's my OC. So I can get from O to point C by going from O to X and then from X to C, correct? So my OC is equal to O to X and then from X to C. From O to X is simply just X. Now what's XC? C is right in the middle of your XY, right? So I can say my XC is half of XY, right? My vector XC is half of my vector XY. And just now we have already found my XY, right? My XY is equal to that. So I'm going to replace this with X plus half of negative X plus Y. And let me bring that up. And so my vector OC is equal to, so X plus half multiply negative X, that gives me negative half X. So I have half X here. And then that goes in, that will have plus half Y, which is half of X plus Y. All right, so OC is a bit tricky. All right, so be careful with that. Now, the last method is CO, vector CO. So vector CO this should be easy. So because vector CO is the negative of vector OC, right? It's the opposite direction. So I'm just going to put the negative of my OC. So this is negative, negative half of x plus y. Right? And that's my part A. Not too bad so far, I think. Now for part B, they want us to express the vector of AB. So from here, I'm going to be vector AB in terms of x and y. Right? So to get from point A to point B, my vector AB, I can go from A to O and then from O to B. Right? So I'm going to put that down. Vector AB is equal to A to O plus O to B. And my A to O is just the negative of my O to A, correct? So this is equal to negative half x plus, what's my OB? OB is right here, right? OB is right there. So this is plus half y. Cool. So that's my vector AB. Now the second part, what's the relationship, right? The relationship between xy, so let me erase this. The relationship between my xy, this line right there, and my line of AB. What's the relationship? So from the picture we have, looks as if they are parallel, right? But we need to actually prove that they are parallel. Okay, so how do we do that? So I'm going to compare my vector AB with my vector xy, which is over here. So I'm going to put it here down there. Vector xy is equal to negative x plus y. And I'm going to compare them. So it seems like from my vector AB, I have a half there, I have a half there. Even though the sign is negative, this one is positive. But maybe I can take out the half and let's see what happens. If I take out the half, I have negative x plus y. Right? But hey, this part is my vector xy. Right? This is my vector xy. Right? So which means I can write my vector AB in terms of vector xy. And what does that mean? That means they're parallel, right? That means they're parallel. Okay? So my vector AB is equal to half of vector xy. Right? So vector xy is all the way there, and my vector AB is sort of half of that. Or, which means my vector AB is the same as my vector XC, right? My vector XC, which is also equal to my vector XC. But the question is not asking us about that, so let's not go there, right? But I hope you guys see that relationship. Alright, so I'm done with B. Now for part C, I'm going to use a different color. Let's use green. For part C, they want us to prove, they want us to find OP, vector OP. And they have already given us what does the vector OP consist of, right? So vector OP, I'm going to do it here. Vector OP is equal to OX. So OX, which means this part, OX plus 2/3 of XB. XB is this, right? But they're not talking about the whole thing, they're only talking about 2/3, so I'm gonna go maybe somewhere there. And this is my, oops. Wait, how's that again? I'm gonna put a point there. This is my B. Ooh. Okay, let me just reset this. Sorry about that. Okay, so I'm gonna have a point somewhere there, and that will be my point P. Okay, somewhere here. Okay, so to find vector OP, which is this one right there, I can go all the way up to X, from O to X, and then from X to P. right? So OP is equal to OX plus XP. And what's OX? OX is equal to X. And what's XP? XP is equal to 2/3, right? 2/3 of XB, right? This is plus 2/3 of XB. And what's XB? XB is, from here, we go all the way down and then come over, right? And so from XB is equal to 2/3 XO plus XO is negative X, right? This is negative X. And then from O to B, that is half Y, right? Plus half Y. Let me print that over here. So this will be X plus 2/3 multiply negative X. So that will be negative 2/3 X. I will have my OP is equal to 1/3 X. Right. And then distribute. 2 and 2 cancels out. I will have plus 1/3 Y. And I can factor the 1/3 out. I'll have 1/3 of X plus Y. So that's it. This is my OP. Okay, now we're almost done, right? We're almost done. I'm going to use red now because this is sort of the last bit, and I would say the most challenging part, right? Because they want us to look at the position of P. So I have my point P right there. Okay, let me erase this. I'm gonna have a point P, and let me bring that. Give me 1 minute. We can set this up. Bring this. Okay. You see what I'm doing here. Okay, forget it. I can't do it. So let's say I have a point P there, right? I have a point P there. Let me try that. Let me try this. Somewhere here. All right. Oh man, that's annoying. Okay, that's point P. Point P, come on. Yeah, thank you. All right. So now they want us to look at the position of point P and sort of come up with a conclusion, right? Conclude about position. What can you conclude about point P? So I'm going to look at my vector of OP. This is a vector of OP, right? This is OP, OP. And I'm gonna look at my vector of OC. Now, if you guys take a look at these two vectors, what can I say about my vectors OP and OC? So this is OP and this is OC. What can you say about them? By looking at this two vectors, OC is equal to half X plus Y, OP is equal to 1/3 X plus Y. Now, I hope your answer is OC is parallel to OP, right? Because this is just some vector X plus Y, and OP also shares the same vector of X plus Y. So they are just half of whatever that vector that they're sharing with, and for OP that would be 1/3 of whatever vector they are sharing, right? So I hope you guys saw that. They are OC, the O vector OC and vector OP are parallel. Now, this vector starts from O, this vector starts from O, so they have a common point. The common point in this case is O, right? Common point O. So you have two vectors parallel and they share a common point. Therefore, points O, C, and P are collinear. Okay? That's it. This is example 11. Pretty tough. It's a tough one. And also a pretty common vector problem. I hope you guys understand the reason why I'm doing every step. And if you don't, write down your questions and I'll see you guys in class, and you can ask me, ask your friends, okay? That's it for now. I'll see you guys later. Bye.